So now we are going to apply our decision tree algorithm with our Python. So the first step here I am doing is nothing but I am just importing my pandas because I am going to read a file. So the variable name pandas dot read underscore csv. So I am just going to read my csv file called train. So this is nothing but we are just going to read our Titanic data set, and I want to make the particular index column, the index position, as I want to make some particular column. So we just run this. Great, it's run. So this data set, that is nothing but our Titanic data set, training data set, which is already clustered in our data set of Kaggle. So for our learning purpose, I just chosen this to apply our decision tree, and I am just applying the head. Now why we are applying the head? So it will give the value. So when we are just giving a print of head, we are just getting the value of survived and P class and the passenger ID who are in the name and for all those things, and the peoples who are having their tickets, everything will be getting. So when we are not giving the print, we'll be getting an output like this. So everything will comes like this. So when we are giving a print, our UI design will be very. So when we are giving a print, it comes like this. So now we are having some data like SBSH, and then this is nothing but a parents children, and then abroad, and then ticket. So now we are going to predict whether a passenger is survived or not. So to predict that thing, we are just going to use some of the data from here as a dependent variable. So from our df, I am just going to get some data. So that's all, nothing but my P class. So I am just copying this, my P class, and then okay, I need to give with the codes, so it's better I am just typing this. So P class, and then based on the sex, and then okay, is S is caps, and then I am just giving something like age, and then I am just giving something like SIB, SP, and then I am giving something like PARCH, PARCH, and then I am giving something like FARE, FARE, and then I am giving something like survived. So this all the things which we needed from our data set. Apart from, we don't need anything else. So the class, sex, age, siblings, parent children, FARE, survived, we get as a df. So df dot head, let's check. Only we are having this much of data set now. So the next step here, we need to go ahead to convert this data to 0 and 1, where we have a male and a female. Now I am planning to convert this to an integer value. So we can able to apply the label encoder and one-hot encoder. But instead of that, I am planning to do some different method. So the variable name, the column name equal the variable name, the column name dot map. What I am just going to do is I am just going to apply the map, and map, which is kind of the iteration stuff in our Python. So male, yeah. So male, that is nothing but my key name I given. That's nothing but our column we are having the male value, and then I am giving a female. This is also the key value. So 1 be given. So let's we run this. So str object has no attribute of map. Yes, the reason is a string object, it doesn't have the inbuilt function of map. So what we need to do is we forget to give the bracket here. That's the reason why we got the error. So now, yeah, so our error is fixed. Great. So now probably this male and a female which is converted to 0 and to 1. So now let's we go ahead with our drop now function. So why we need to apply drop now? Because we are planning to remove all the NaN values from our data set. So we are just applying the drop now. So after we apply the drop now we want to make our x and y. So I am just going to make a x and y from my df. I am just going to drop my last column, that's nothing but a survived, because that's my target now. So axis equal to 1, that's nothing but a column based. Then y value I am just going to get only survived. So now we created our x and y like this. Great. So now we created our x and y. Our next step here is we need to apply our training and testing. So from scientific-land dot model underscore selection, we are going to import our training and testing. So I am just giving import train underscore test underscore split. So then again what I am just giving is the variable name, the variable name underscore train underscore, then again the variable name test underscore, again I am just giving a train comma y underscore test equal to train underscore test underscore, and then split. We are going to apply this to our x and y. So x comma y comma, now we are just giving our random state which is going to give 1. So now we are just applying this. So hope everything is fine here. Train underscore test underscore y train y test, where we need to give this 4 argument and we get this splitted and xy perfect. So everything is a perfect now here. So now we are just going to get our model. So our decision tree model here we are going to apply. So for that perspective I need to import from my tree. So in this tree I am going to get my decision tree classifier. So I am just giving decision tree classifier. So we done this. Great. So now when we are just running this, now we got the decision tree classifier. So now we are just getting the model, that's nothing but the variable name. This is actually our stuff. So when we are having a minimum impurity decreases 0.0, then which is used to actually help to prevent the overfitting the model of the training data set. If our data set is overfitted, then we will get some value like more than 1. So now we are just having this decision tree model which is based on the Gini model. So now we need to fit our data model to our training data set. So let's fit that. So the variable name dot fit. Now we are going to fit with our train and our y train. So we are just fitting this. Okay, x underscore train is not defined. Yes, because x is caps. Great. So we got the output. Now we just fitted our value and we just having this thing. Now we need to predict our output from the model on our test data against our ground truth data. So let's create another variable name called y predict equal model dot predict. I just give like this. We are just going to apply this for our test. So now we just apply the prediction. After that we need to get the accuracy score. So to get the accuracy score, I am just importing my matrix and I am just importing my accuracy score like our logistic regression. So I just imported my accuracy score and then now I am going to calculate the accuracy score for my y test and y predict. So y underscore test comma y underscore predict. So we are getting an output because it's means the R. So our accuracy score is 82%. which is significantly better. So 50 out of 50 guessing, we are just to get this output. So now we need to apply the confusion matrix to come to know the wrong predicted and the actual prediction output. So we import our scientific kitlan here. So I am just giving from sklan dot matrix. We are just importing our confusion underscore matrix. So then I am just going to frame a data. So for confusion underscore matrix, I am just giving y underscore test comma y underscore predict. Okay, now we just created this. So our output which we are getting like this. So 97, 15, 17 and then 50. So this is actually, we predicted not survival and we predicted survival. So here we are just giving true not survival and true survival peoples. So you predicted someone as a 97. So you predicted them as a not survival. So the actual output of 97 plus 15 is actually the total value. So predicted is as a survival as a 15 and predicted not survival as like here is 60 and here is a 50. So to get to know the better understand, so we will just frame the data again. Let's copy this here and I'm just pasting. So to come to know the better thing, so what we can just given is, we can able to give the columns and the index. So I am just giving a columns. Let's give predict not survival, and then I am just giving something like predict survival. So and then let's give the index. So index equal, what we are just going to given is true not survival, actually true not survive, and then what we are just going to give is true survive. Great, we just run this. So we are getting a value error because of some mistake which we made here. Let's check what will be the mistake. So confusion matrix, y test, y predict, and then columns equal to, we just give to list comma index equal, we just given to list. Looks seems everything is perfect here. So let's wait. Let's check what will be happening here. Yeah, so here we made a mistake of not giving the thing correct. Super. So now we got the columns. So we can able to make some graph format to come to know either the particular thing is how this categories was happen. So to come to know those things, we need to import some graph which module to get our modules in our decision tree. So by using that modules, we can able to check how this performance classified by using our decision tree. So anyhow, so now we just discuss about how to get the output and how to get the things by using our decision tree and random forest. Decision tree. So we need to cover about the random forest. So here we just created our data set, and in the data set is nothing but our Titanic data set. We just made the peoples, so 0 and 1. So we just predicted the peoples who are survived, who are not survived based on our decision tree by applying multiple functions. So finally here also we are just going to apply zeros and ones. That's it. So now we just applied our decision tree with Python. The next concept is our random forest.